Welcome to The Explainer. Today, we're going to crack open the fascinating world of epistemic logic. We're going to explore how logicians and computer scientists are trying to teach machines a skill that is so fundamentally human, how to recognize what they don't know. All right, let's just jump right in with a question that sounds pretty simple on the surface, but for artificial intelligence, it is incredibly complex. I mean, for you and me, there's a world of difference between saying, I don't have that information, and I have some information, but I'm just not sure about it. But for a computer, that's a whole different ballgame.
And this gets right to the heart of the challenge. It's something logicians call the logical omniscience problem. You see, standard logic just assumes that if a machine knows a few facts, it also instantly knows every single possible thing that follows from those facts. It's basically a perfect, godlike reasoner. But that's not how we work, is it? Our attention is limited, we forget things, and we definitely don't compute every possible outcome of a situation.
So to get away from that perfect reasoner model and create something a bit more realistic, logicians had to start with the most basic kind of not knowing. Just plain old ignorance.
You know, the old school way of thinking about this was super black and white. Ignorance was just the absence of knowledge. If your brain's database doesn't have the entry, "it is raining," marked as true, then by definition, you are ignorant about the rain. It's just an empty slot where a fact should be. Simple as that.
But, and you knew there was a but coming, this really simple, black and white definition runs headfirst into a very human-sized problem. It turns out that not all not knowing is created equal. For example, if I ask you that question on the screen, your reaction is totally different than if I asked, "Will it rain in London tomorrow?" You're not just missing a piece of information. Your state of not knowing is way deeper, because you don't even know what the words mean. What on earth is a flurg, and what does it mean to snork?
And that right there perfectly shows the crucial distinction logicians had to figure out. On the one hand, you have traditional ignorance, which is just a lack of information. But on the other hand, you've got what's called content theoretic ignorance, where you're unfamiliar with the actual concepts in the question. And to really model a human mind, a logic system has to be able to tell these two apart.
Okay, so we've got these different flavors of ignorance, but now let's talk about its more complex cousin, doubt.
See, unlike ignorance, which can feel like an empty box with no information, doubt is totally different. It's a state of graded belief. It's not just a simple yes or no. You have a certain level of confidence based on the evidence you have, even if that evidence is partial or conflicting. You're pretty certain the sun will rise, but you're only kinda sorta certain it will rain.
So here's the key takeaway, right? Doubt isn't some passive state. It's an active mental process. It's your brain churning, weighing possibilities, and wrestling with uncertainty. It's that messy middle ground where most of our real-world thinking actually gets done.
So how in the world do you teach a computer all this nuance? To actually model these incredibly complex states of mind, from not knowing what a flurg is, all the way to feeling 60% sure about something. Logicians basically had to invent a whole new toolbox.
Now, for tackling that really deep what's a flurg kind of ignorance, they came up with some really clever tricks. First, some systems just add a third truth value. It's not true, it's not false, it's more like, huh? Second, they build in this concept of unawareness, which basically acknowledges that we aren't even thinking about most things at any given time. And finally, some models just give ignorance its very own special operator, treating it as its own thing, not just a lack of something else.
Okay, so that's how we can start to model ignorance. But for doubt? Well, for doubt, the toolbox gets even more creative. We're moving way beyond simple true or false now.
The first tool is one you're probably already familiar with, even if you don't know its fancy name: probabilistic logic. This just lets a machine assign numbers or credences to its beliefs. It's exactly like a weather forecast giving a percentage chance of rain. It lets an AI say, "I believe this is true," with about 60% confidence.
Then there's the second, really fascinating tool. It's called Belknap-Dunn logic, and it was originally developed to help computers handle messy, inconsistent data. And as you can see in this table, it doesn't just have two truth values, it has four. You've got your standard true and false, but then you have neither, for when there's just no information, perfect for doubting a coin flip. And you also have both, for when you have conflicting information, like a paradox. It's a system truly built for our messy world.
And finally, and this one is a real game changer, logicians developed what are called non-normal logics. These are systems designed from the ground up, specifically for imperfect, limited reasoners. Like us. They intentionally throw that old, unrealistic assumption of logical omniscience right out the window.
A key idea here is something called
neighborhood semantics, and this quote just nails it. In normal logic, thinking is like a direct flight. If you know A and B, you instantly arrive at C. But in a neighborhood model, it's more like your thoughts live in a neighborhood. Knowing a couple of facts gives you access to other closely related ideas, but not necessarily to every single thought on the other side of town. It's just a much more realistic way of thinking about how we connect ideas.
Okay, so we filled up our toolbox with all these clever models for ignorance and doubt. But after all this abstract theory, you have to ask the big question. So what? Why does any of this actually matter in the real world?
Well, the applications are huge. For AI, it means we can build systems that don't just blindly follow orders until they mess up, but can actually recognize the limits of what they know and say, hey, I don't understand. Can you clarify? In economics, it lets us create much more realistic models of how actual people make decisions. And honestly, it gives all of us a powerful new way to think about our own minds and their limits.
So when you boil it all down, what we're really talking about is this massive shift in thinking. We're moving away from designing a logic for perfect, idealized gods, and we're finally starting to build a logic for mortals, a logic that understands and even respects our real-world limitations.
And that leaves us with one last big idea to chew on. Building an AI that actually knows what it doesn't know is a monumental step forward, but it makes you wonder, right? If a machine can truly learn to model its own doubt, its own uncertainty, could that be the very first step on the path to something we might one day call artificial wisdom?